Everybody, this podcast is to help you with salt hydrolysis and get you ready for the lab on Monday so you can do your pre-lab. So first of all, what determines the pH of a salt solution? We've been talking about pH of acids and bases and weak acid and weak bases, but salt solution can also have a pH. And what determines the pH of that salt solution? The pH of a salt solution is determined by hydrolysis of ions from the salt. When either the cation or anion hydrolyzes. Hydrolysis means it reacts with waters H plus or OH minus to either increase H plus or OH minus. We call that process hydrolysis. And if no ions hydrolyze, then the pH is that of water. pH of salt solution is that of water, because when no ions are hydrolyzing, H plus and OH minus are in equal concentrations given by Kw of water, and in that case pH is 7. But if salts ions hydrolyze, then the pH changes. So how do we determine which ions will hydrolyze? The ions coming only from a weak acid or weak base will hydrolyze. If cation is coming from a weak base, then it will hydrolyze. If the anion is coming from a weak acid, then it will hydrolyze. Let's practice it here, guys. So let's look at NaCl. This is cation, this is anion. This cation, which base do you think it comes from? And an easy way to think about it, add OH minus to it. So when Na plus is added to OH minus, what base you make? NaOH. Is it strong or weak? It is strong. So this will not hydrolyze. Cl minus, add a H plus to it. Anion, you add a H plus. So that is HCl. That's a strong acid. So again, this one will not hydrolyze. So in case of aqueous NaCl, neither ion hydrolyzes. So its pH of salt solution or aqueous NaCl will be 7 as determined by Kw of water. Now let's look at Na2CO3. Na comes from NaOH. This one will not hydrolyze. CO3 comes from H2CO3. How do you think of that? Just think of the weak acid that you kind of know. This one is a weak acid, so yes, CO3 2 minus will hydrolyze. Let's try one more. NH4 plus comes from the weak base ammonia, and yes, this will hydrolyze. HCl comes from, Cl minus comes from HCl, so this one will not hydrolyze. And once we determine what hydrolyzes, now we can write equations. So hydrolysis means breakdown of water, or the ions, either cation or anion, reacts with H plus OH minus to change the balance of H plus and OH minus, making it either acidic or basic. And the way I remember is if an anion is hydrolyzing. Anion has negative charge. Think of water as H plus OH minus. If anion hydrolyzes, it will increase OH minus, same charge, right? So it will raise the pH. pH will be basic. If cation hydrolyzes, then cations positively charged. It will increase the H pluses concentration, so pH is acidic. So your first step in figuring out the pH of a salt solution is to determine which ion or neither will hydrolyze. Once you have identified that, now you got to write the equations. If an ion hydrolyzes, then the general equation is A minus plus water gives you HA plus OH minus. Think of water as H plus OH minus, so opposites attract. A plus will go with H plus forming HA, and then OH minus will be left over. Because you are increasing hydroxyl ion concentration, we'll write a Kb or base equation, because increasing hydroxyl ion will make it basic. Pure liquids and solids don't get added, so the Kb expression is HA OH minus over A minus. And if the cation hydrolyzes, then it is BH plus for cation. H2O gives you equilibrium sign both places. B plus H3O plus. So Ka, this time we'll write Ka because we are increasing H3O plus. So it makes H3O plus B over BH plus. Now, how it applies to your lab that you will be doing on Monday and the pre-lab that you'll be doing today. The pre-lab is on page 35 for this lab. And for this lab, you have to predict what the theoretical pH of 0.1 molar solution of different salts would be, and then actually test it and find percent error. Before going here, let me actually take an example. Let me take an ion that will hydrolyze. How about zinc nitrate as an aqueous salt, right? If you have zinc nitrate, what do you zinc elements, which one will hydrolyze? Zinc, the base you can think of as zinc hydroxide, right? Nitrate, nitric acid. Nitric acid is strong acid, this one won't hydrolyze. Zinc hydroxide, weak base, this one will hydrolyze. So I've determined which ion will hydrolyze. So I write zinc ion and the cation equation as we wrote in the back, plus water, think of HOH. This is plus, this is minus. Opposites attract, so Zn will go with OH, forming Zn OH only plus 1, because plus 2 minus 1 plus 1, AQ plus H plus. Now in this case, because we are increasing H plus ion concentration, would we write a Ka or Kb? Yes, we'll write a Ka because we are adding more H plus, making it acidic. And then you write ZnOH plus H plus over Zn2 plus. That will be my Ka expression. Now, couple of things, and this is how you will fill in the pre-lab table, identifying which ion or both or none will hydrolyze and writing these either Ka or Kb or Kw. If neither ion hydrolyzes, then you write Kw expression. And let me show you where you'll do it. Let me just quickly grab a packet. That was the bell. Okay, so you will be filling out in this table, right? So first of all, you will determine, like in case of sodium acetate, let me walk you through this one. It is already given here. So sodium comes from, if you add OH minus, it comes from NaOH. Strong base will not hydrolyze. Acetate comes from acetic acid. Yes, it will hydrolyze. So we identified the ion that will hydrolyze. The spectator ion, the one that won't hydrolyze, is sodium ion. Now, how would we write the equation? Remember, plus means this one is hydrolyzing an ion. So you can reference this equation. Anion hydrolysis, we write acetate plus water following the same pattern. HA, you form acetic acid and OH minus. And because you're increasing OH minus, you are writing a Kb expression, products over reactants. And the Kb is given here. If you can't find it, you can Google it and calculate theoretical pH using ice charts. Okay. I need to see work for at least one full complete line, including how you calculated theoretical pH. Okay, if you do not show work even for one row, you will be marked down. So you must show work for one row, and then you can just calculate. You don't need to do repeated work for each one for the theoretical pH part. Now from there, guys, one other thing I wanted to tell you. When you come to carbonate, like sodium carbonate, carbonate has 2 minus charge, right? It is a two-step process. It has a Ka1 and Ka2. Remember, we only use the first step. because first step makes so many more H plus as compared to second step. I wrote the wrong equation here. This is the Ka equation. I didn't write hydrolysis because I don't want to show you hydrolysis. You will write hydrolysis reaction starting with carbonate and water, right? But you will only do it for step 1 because that makes the most H plus ions. Similarly, for Al3 or multiple charge things, you'll only use first step, okay? Now, one other thing you need to know. For first step, you will be writing if this is making, so the first step's Ka1 and last step's Kb. So Ka1 times Kb2 in a diproduct, in a two-step dissociation is equal to Kw. In a three-step dissociation, Ka1 of the first step times Kb3 of the, or the B3 of the last step is Kw. And why I tell you this is, as you look at the values, for aluminum hydroxide, they've only given you Kb3, but you will require Ka1 value for it. You have two choices. Either you can look for Ka1 value from online, or you know that Ka1 times Kb3 is Kw. And that's how you can calculate Ka1, because you will be using only first dissociation or Ka1 value. Similarly, for copper, you know Ka1 times Kb2 is Kw. You want to figure this out because you're only doing first step. That this Kb2, if you divide Kw by this value, then you can calculate it. Okay, I do want you to use these values, and rest all, there is no appendix D, but remember on page 18 I have a value. You can use that, or you can use Google. Thank you, elements, and I will be grading your pre-lab on Monday. I'll see you soon.